Welcome to MindTier Learning, where GCSE Geography is made simple. This presentation will guide you through effective strategies and tips to help you prepare confidently for your GCSE exams. Together, we'll explore ways to make your study sessions more productive and manageable so you can approach your exams with less stress and better results. Let's get started. Welcome to today's lesson on depositional landforms. In this lesson, we are going to look at how the sea builds new coastal landscapes from sand, shingle, mud, and sediment. So far, we have looked at erosion and transportation. Erosion breaks material away from cliffs and rocks. Transportation moves that material along the coast. Today, we are looking at what happens when the sea loses energy and drops the material it has been carrying. That process is called deposition. Deposition is responsible for some of the most recognizable coastal landforms, including beaches, spits, bars, tombolos, sand dunes, and salt marshes. The big question for today is, how does the sea build new coastal landforms, and why are these features important? Let's begin with today's learning objectives. By the end of this lesson, you should be able to do 4 things. First, you should be able to identify the role of deposition in coastal formation. Deposition happens when the sea loses energy and can no longer carry its load. This is how sediment is dropped and new features begin to form. Second, you should be able to explain how beaches and sand dunes develop. Beaches are mainly built by constructive waves, while sand dunes develop when wind blows dry sand inland and plants help trap and stabilize it. Third, you should be able to describe the formation of spits, tombolos, and bars. These are depositional landforms linked to longshore drift and changes in coastline direction. Finally, you should be able to understand the importance of pioneer species in salt marshes. Pioneer species are the first plants to colonize a new environment. They help stabilize sediment and begin the process of ecological succession. So today's lesson links physical geography with ecosystems. We are not just looking at landforms, but also how those landforms become habitats. Before we go further, let's go through the key vocabulary. The first word is deposition. Deposition is the process where material being transported is dropped because energy levels have fallen. At the coast, this can happen when waves lose energy in sheltered bays, behind spits, or in shallow water. The second word is spit. A spit is an accumulation of sand or shingle extending from the land out into the sea. One end is attached to the land, while the other end extends out into open water. The third word is tombolo. A tombolo is a ridge of sand or shingle that connects an island to the mainland. It forms when sediment builds up between the coast and an offshore island. The fourth word is succession. Succession is the process where plants colonize a new environment and gradually change it over time. On coasts, succession can happen in sand dunes and salt marshes. These words are important because they help us explain not just what landforms look like, but how they form and develop. Before the sea can build landforms, it has to move material. In the last lesson, we looked at the 4 main methods of coastal transportation: traction, saltation, suspension, and solution. But today's key question is, why does transportation stop? Transportation stops when the sea loses energy. This often happens in sheltered bays, behind headlands, behind spits, or where water becomes shallow. When wave energy is high, the sea can move larger particles such as pebbles and boulders. When wave energy falls, the sea can no longer carry its load, so material is deposited. The slide gives us a key point. Higher energy means larger particles can be moved. Lower energy means particles are deposited. This is why beaches often sort sediment by size. Larger pebbles may be left higher up the beach where wave energy is strong, while finer material may settle in calmer water. So deposition is all about energy loss. Let's do a quick transportation check. You need to match the transportation process with its definition. The processes are 1. Traction, 2. Solution, 3. Suspension, 4. Saltation. The definitions are: A. Small pebbles bounced along the seabed. B. Fine silt and clay particles carried in the water. C. Large boulders rolled along the seabed. D. Minerals dissolved and carried in the water. Take a moment to match each term. Remember, traction is rolling. Saltation is bouncing. Suspension is floating within the water. Solution is dissolved material. Let's go through the answers. Traction matches with C, large boulders rolled along the seabed. Solution matches with D, minerals dissolved and carried in the water. Suspension matches with B, fine silt and clay particles carried in the water. Saltation matches with A, small pebbles bounced along the seabed. These processes explain how material gets moved along the coast. But once wave energy drops, that material is deposited, helping to build new landforms. Now let's look at the most familiar depositional landform, the beach. A beach forms when sand, shingle, or pebbles are deposited along the coastline. Beaches are usually built by constructive waves. Constructive waves have a strong swash and a weak backwash. The swash pushes material up the beach. The backwash carries water back down the beach, but because it is weak, it does not remove as much sediment. This means more material is pushed up the beach than is taken away. Over time, the beach builds up. The type of beach depends partly on wave energy and sediment size. Fine sand is usually found where wave energy is lower. Chunkier pebbles and shingle are often found where wave energy is higher, because smaller particles may be washed away while larger material remains. So if you see a sandy beach and a pebble beach, they are not random. They tell you something about wave energy, sediment supply, and coastal processes. The key idea is, constructive waves build the coastline. Destructive waves erode it. Now let's look at spits. A spit is a narrow ridge of sand or shingle that extends from the land out into the sea. Spits form because of longshore drift. Longshore drift moves sediment along the coastline in a zigzag pattern. A spit often begins where the coastline suddenly changes direction, for example at a river mouth or estuary. Longshore drift continues to move sediment along the original direction of the coast. But when the coastline changes direction, the water becomes deeper or more sheltered. Wave energy drops, and the sediment is deposited. Over time, the deposited material builds out from the coast, forming a spit. The end of the spit may become curved or hooked. This often happens because of changes in wind direction or wave direction. Behind the spit, the water is sheltered and low energy. This can allow mud to settle and salt marshes to develop. So a spit is created by the interaction of longshore drift, energy loss, and deposition. Now let's compare two related landforms, bars and tombolos. A bar forms when a spit grows across a bay. If longshore drift continues to deposit sediment, the spit may eventually stretch all the way across the bay, cutting it off from the sea. When this happens, a lagoon may form behind the bar. A lagoon is an area of shallow water separated from the sea by the bar. A tombolo is different. A tombolo forms when a ridge of sand or shingle connects the mainland to an offshore island. This happens because wave energy is reduced in the sheltered area between the island and the mainland, allowing sediment to build up. So the difference is, a bar crosses a bay. A tombolo connects an island to the mainland. Both are formed by deposition, but they connect different things. Let's check your understanding. The question is, what is the primary difference between a spit and a bar? Is it 1. Spits are made of sand while bars are made of clay. 2. A bar spans the entire bay, while a spit has one open end. 3. Spits only form in cold climates. 4. Bars are always submerged, but spits are not. Take a moment to think. A spit extends from the land, but does not fully close off the bay. A bar stretches across a bay and can cut it off from the sea. The correct answer is 2. A bar spans the entire bay, while a spit has one open end. This is the main difference. A spit is attached to the land at one end and extends into the sea. A bar stretches right across a bay, cutting it off from the sea. Option 1 is wrong because both spits and bars can be made from sand or shingle. Option 3 is wrong because spits can form in many climates. Option 4 is wrong because bars are not always submerged. A strong GCSE answer should be able to explain both the shape and the process of formation. Now let's move from the beach to the land behind it. Sand dunes are coastal landforms built by the wind. They form when dry sand is blown inland from the beach and begins to accumulate. But loose sand is easily moved, so for dunes to grow and become stable, something has to hold the sand in place. This is where pioneer species are important. Pioneer species are the first plants to colonize a new or harsh environment. On sand dunes, a key pioneer species is marram grass. Marram grass is well adapted to dry, sandy conditions. Its long roots help bind the sand together, and its leaves and stems trap more wind-blown sand. As sand builds up around the grass, the dune grows taller. The slide notes that marram grass roots can grow up to 3 meters deep to find water in dry sand. This makes marram grass extremely important in dune development. Without pioneer species, sand dunes would be much less stable and could be blown away more easily. Now let's look at how sand dunes change as you move inland. This process is called Samazir succession. A Samazir is a succession sequence that begins in sand. Near the beach, conditions are harsh. There is lots of salt spray, strong wind, dry sand, little soil, and few nutrients. Only specially adapted pioneer species can survive there. These early dunes are often called yellow dunes because they contain lots of bare sand and are still mobile. As plants grow and die, organic matter is added to the sand. This slowly creates more soil and improves conditions. Further inland, the dunes become more stable and may be called gray dunes because there is more vegetation and humus. Eventually, if succession continues, the area may develop into grassland, scrub, and even woodland. So dune systems are not just piles of sand. They are living landscapes that change over time. Now let's look at salt marshes. Salt marshes form in sheltered, low-energy coastal environments. They often develop behind spits, inside estuaries, or in areas protected from strong wave action. Because the water is calm, fine sediments such as mud and silt can settle. Over time, this builds up into mudflats. Then pioneer plants begin to colonize the mud. These plants must be able to tolerate salty conditions and regular flooding by tides. As the plants grow, their roots trap more sediment and stabilize the surface. Over time, the marsh builds upwards and becomes more established. Salt marshes are extremely valuable. They provide habitats for birds, fish, and invertebrates. They act as natural sea defenses by absorbing wave energy and storing floodwater. They can also store large amounts of carbon, making them important carbon sinks. So salt marshes are both physical landforms and important ecosystems. Now let's apply your knowledge. The question is, imagine a local council wants to build a car park on a salt marsh behind a spit. Why might geographers and environmentalists argue against this? There are several possible reasons. First, salt marshes act as natural coastal defenses. They absorb wave energy and reduce flood risk. If the salt marsh is removed, nearby land may become more vulnerable to flooding and erosion. Second, salt marshes are important habitats. They provide feeding and breeding grounds for birds, fish, and marine life. Third, salt marshes store carbon. This means they help reduce the amount of carbon dioxide in the atmosphere. Fourth, interfering with depositional features can disrupt the coastal system. If sediment movement changes, erosion may increase elsewhere. So building on a salt marsh may provide short-term economic benefits, such as parking or tourism access, but it could cause long-term environmental and flood management problems. You might have said that salt marshes act as natural sea defenses by absorbing wave energy. That is correct. You might also have said that they are vital habitats for rare birds and marine life. That is another strong point. The slide also notes that salt marshes store more carbon than rainforests. This makes them valuable carbon sinks. You might also have said that interfering with depositional features can increase coastal erosion. A strong GCSE answer might say, geographers and environmentalists might oppose building a car park on a salt marsh because salt marshes provide natural flood protection by absorbing wave energy. They are also important habitats for birds, fish, and other wildlife. Salt marshes store carbon, so removing them could reduce carbon storage and contribute to climate change. Building on the marsh could also disrupt sediment movement and increase erosion or flood risk elsewhere. That answer is strong because it considers physical, ecological, and climate-related impacts. Let's finish by summarizing today's lesson. Today we explored how deposition creates diverse coastal landscapes. Beaches form when constructive waves deposit sand, shingle, or pebbles along the coast. Constructive waves have a strong swash and weak backwash, so they push more material up the beach than they remove. Spits form when longshore drift moves sediment along the coast, and the coastline suddenly changes direction. Energy drops and sediment is deposited, building a ridge out into the sea. Bars form when a spit grows across a bay, cutting it off from the sea and sometimes creating a lagoon. Tombolos form when deposition connects the mainland to an offshore island. Sand dunes form when wind blows dry sand inland and pioneer species, such as marram grass, trap and stabilize it. Salt marshes form in sheltered, low-energy environments where mud and silt are deposited and colonized by salt-tolerant plants. The reflection question is, which landform do you think is most vulnerable to climate change? You might choose salt marshes because sea level rise and coastal squeeze could drown or squeeze them out. You might choose sand dunes because storms and trampling can damage them. You might choose beaches because stronger storms can remove sediment and create a negative coastal budget. The key idea is that depositional landforms are valuable but fragile. Thank you for watching. If you found this lesson helpful, please remember to like the video and subscribe to our channel. Your support means a lot and helps us continue to provide valuable content. Don't forget to hit the notification bell so you never miss an update. See you next time.